This video is on the formation of carbon-carbon bonds. As mentioned in an earlier video, we said that organic synthesis can be used to convert something like methanol into something like heroin. Well, if we're going from a single carbon molecule into a molecule with 20 plus carbons, it's safe to say that we're going to have to be able to make carbon-carbon bonds. So the whole purpose of making carbon-carbon bonds is that it allows us to extend the carbon chains and make bigger molecules. Well, if we're doing substitution reactions, what do we need? We need carbon nucleophiles, so that a carbon anion will attack the electrophile, kicking out a leaving group to form a carbon-carbon bond. The most common carbon nucleophile is cyanide, which we've encountered many times. It is an extremely good nucleophile for SN2, and that's all you need to know. If you mix sodium cyanide with an alkyl halide, for example, you will most likely get SN2 chemistry. What is the product of the following reactions? You may pause now. And here are the answers. Now, of course, you might be wondering, well, that just adds one carbon and then it ends with the nitrogen. Well, there are many reactions that we can do to modify the cyanide into other things and even get rid of the nitrogen if we wish to do so. But that would be organic too. We won't worry about it for now. Another strong carbon nucleophile is a terminal sp carbon, as long as it's deprotonated. So what am I talking about? I'm talking about a terminal triple bond. That proton, as we recall, is acidic compared to other carbon-hydrogen bonds. So if we have a strong enough base, such as sodium amide, right here, it will give us a terminal nucleophile. That is a pretty good carbon nucleophile. If we now mix this with an alkyl halide, for example, we can definitely extend the chain effectively. Now you have a go. What would be the product of this reaction? You may pause now. And here is the answer. Now, another favorite is ethyne. So just the triple bond with two hydrogens available. What would be the product of this sequence of reactions? You may pause now. And here is the answer. There are many more carbon nucleophiles, but we will encounter those later in organic too.